maybe.
5 more chapters to do, we're gonna do test after lunch, okay?
Okay.
You've been 43, right? 495?
Yeah.
Good. Any questions on yesterday? We'll go back over a little bit of this if we have time today, but everybody got that down pretty good, what we did yesterday?
Si, senor.
Okay. Chapter 43 deals with oscilloscopes, graph and multimeters. Basically, all that is it's just like a meter that has a screen, and rather than just a digital display, it will show waveforms, okay? So voltage and stuff like that in an actual waveform that you can see rather than just a number, okay? Basically, all it is, okay? So what I'm going to do as we go through this, I'm going to do what I did yesterday. I'm going to kind of give you a little bit of an idea of what you're going to see on the test, okay? Because again, you can't absorb all of this and there's no need to. Okay?
Okay.
All right. I'm going to go through the different types, explain time-based volts per division. This is something that's going to show up on the test, and I'll tell you what you're going to need to know about time-based and volts per division settings on the meter, okay? Difference between AC and DC coupling on the waveforms from the oscilloscope. How to interpret the waveforms. There's things called pulse trains, channels and triggers on the scope, how to use those. A lot of scan tools now have the option of looking at a waveform on the scan tool as well. So sometimes you don't need the separate oscilloscopes like you used to need because scan tools weren't that advanced years ago. But a lot of the nicer, more expensive scan tools, you can actually look at waveforms on them, okay? So again, you don't have to have a separate meter to do things like this. All right. Oscilloscope is called a scope. It's just a visual voltmeter with a timer that shows when the voltage changes. The advantages of these is you can actually see something happening that you might not be able to see on just a number display. Okay. Analog scope uses a CRT and a digital scope uses an LCD or liquid crystal display. You need to know that. You're going to see it later, later today, okay? Make sure you make a note of that, highlight it, whatever you got to do. You're going to see it later. Got it?
Yeah.
Okay. Differences is the type of display that they use, okay? Analog uses CRT or cathode ray tube, and the digital uses an LCD. Everybody's heard of LCD, right? Liquid crystal display. Did you ever know that that's what it was? No? Okay. You haven't heard of that? Okay.
I've heard of LCD, but I didn't know that's what it was.
Yeah. Okay. On the grids, usually the face has 8 or 10 grids, vertical and up and down, 10 grids horizontal, left to right. You guys know the difference between an X and a Y axis?
Yeah.
Yes.
Okay, everybody should know that. I think they taught you that in school, right? Okay. There's going to be a test question on that too, okay? So make sure you know the difference between an X and a Y axis, okay? All right. The scale for reference and measurement is called a graticule. Voltage is displayed on the scope starting with 0 at the bottom, higher voltage being displayed vertically, okay? The scope illustrates time left to right. So it would be like this, time and voltage, okay? Voltage being the vertical, time being the horizontal, okay? That will allow you to take voltage measurements and voltage patterns Each vertical division is 1 volt, has a horizontal division set to represent 50 milliseconds. Now you can change these to whatever you happen to be doing or whatever voltage you're looking at and whatever you want it to do. Okay. Setting the time base, that means how much time is displayed on each block or division of the screen, okay? Volts per division should be set so that the entire anticipated waveform can be viewed. So what you do is you just set it up based on what you expect to see, so you can see the whole waveform, okay? So there's your little scale telling you 1 millisecond, 10 milliseconds, up to 1,000. Total time displayed on the right. One on the left is milliseconds per division on the screen, all right? So what you're looking at here is a waveform sweep test on a throttle position sensor. So instead of looking at the voltage on a digital multimeter, if you were looking at it on a screen as a waveform, this is about what you would see. Remember we talked about throttle position sensor voltage? What is it normally at idle? We've talked about this many times. Anybody remember?
It was like 17.21, or is that something else?
Right.
Oh, 0.5 volts.
Half a volt. What does this say?
Half a volt.
If this is 0 and this is 1 volt, where does it start at? Okay, and now, pushing on the accelerator pedal, opening the throttle, right?
4.5.
It ends up at wide open throttle somewhere around 4.5. Right? It's going to tell you the minimum and maximum that it was displayed as well. 4.72, minimum was 0.680, approximately half a volt there, okay? All right. Anybody familiar with AC voltage? Yeah?
Quick question, so does this mean that when you're reading, the scope, that anytime the voltage hits the max level, that's the trigger point?
No, that's just what's gonna display whatever the highest and lowest it saw. It's gonna show minimum and maximum, okay? You have to set the trigger point on it.
Oh, you have to set it?
Yeah, wherever you want it.
Oh, okay, now I understand what it's saying.
Okay, DC flows in one direction, alternating current changes direction continuously, voltage varies over time. Waveform is a sine wave for AC, everybody knows that, right? Okay. AC and DC coupling, I think, let me see, I think there might be a question on AC and DC coupling on here. Okay, maybe not on this one, okay. All right, DC coupling is the most used position on the scope because it allows the scope to display AC and DC voltage signals are present in the circuit. AC coupling is a position selection capacitor is placed between the meter leads, which effectively blocks the DC signals, allows the AC portion to pass and be displayed. Okay. When we get into alternators, you'll understand this a little bit better. This is what they call ripple voltage. It's created from the AC voltage from an alternator. Because remember I told you alternators create AC voltage, right?
Yeah.
Then it's converted to DC. If it's not properly converted, you'll get too much ripple in your system, right? A little bit of AC, okay? Normally, if that happens, you have a bad diode in the alternator or rectifier bridge. Difference is, all right, A pulse train, that is a frequency and number of cycles per second measured in hertz. Duty cycle, we talked about before, it's a percentage of on time. Pulse width is a measure of the actual on time measured in milliseconds. Pulse width is always going to be measured in milliseconds. Duty cycle is in percentage. So if you have a 70% duty cycle, it's going to be displayed as 70%. Means it's on 70% of the time, off 30% of the time. Okay?
Gotta go down my card real quick and grab my highlighter.
Okay, a pulse train is any electrical signal that turns on and off or goes high and low in a series of pulses. Ignition module, fuel injector are examples of a pulse train signal. Going to be a question on the test about pulse trains. Let's see what it says. Okay. Okay, I guess there isn't. I thought there was. Okay, so
No, it's here. A pulse train is any electrical signal that turns on and off or goes high and low in a series of pulses. Ignition module and fuel injector pulses are examples of a pulse train signal.
yeah, I was thinking there was a question on the test about that. That's what I was getting at, yeah. All right. This is a representation of a complete cycle showing on and off time. Feeder display indicating on time in percentage. Notice the trigger and negative symbol. Okay. Most automotive computer systems control a device by opening and closing the ground to the component. Sometimes it will do it the other way around, depending on whether it's a high or low side driver, but most of the time it controls the ground side of whatever it's controlling, okay? You have a continuous power and it controls the ground side. Okay, these are just different channels. If a single channel scope is just capable of displaying only one sensor signal waveform at a time, 2 can do 2 separate ones at the same time, and a 4 will allow you to view 4 at the same time. Pretty simple. Single, 2-channel, 4-channel. Okay, it's just how many you can see at once. All right. 2-channel scope. This is just viewing 2 waveforms at the same time. Again, this is just basic. Your trigger level. There's an external. This is when the waveform starts when the signal is received from another external source rather than from the signal pickup lead. Trigger level must be detected by the scope before the pattern is displayed. Trigger slope is the voltage direction the waveform must have in order to start the display. Difference between a positive and negative trigger is trigger slope is the voltage direction that the waveform must have in order to start the display. Scope leads, nothing really to see there. Most have both analog and digital. Normally use the same test leads. Measuring battery voltage with a scope. Very easy to do, great way to practice the techniques. Okay. On this particular slide here, we have battery voltage shown at the left of that as a flat horizontal line. So can you tell what was going on with this, in this picture here? I know it's probably not big enough to see from the back.
It looks like it started off normally, then it took a nosedive.
Okay.
And then it came back up.
So the start of the signal was 12.8 volts, okay? That was right here. Okay? Got that? Okay. What happened here?
It took off some of the battery.
It dropped down to 10.1. What happened?
The car started.
What's that?
Car started. I started the car.
Okay, exactly. This is the engine cranking, right? Dropped the voltage down to 10 while the engine was cranking, right? Engine started. Alternator starts charging, ends up at 13.8. Okay? This was just normal key on. This was start. And this was running. Okay? Easy to see on a waveform. Obviously, you can see it on a digital meter as well. The scope gives you the opportunity to actually watch it and see if there was a problem with a circuit or a voltage signal, something like that. It would be easier to look at it than it would be to try to catch it on a meter as just a number.
The voltage, it goes down, and then you said it's hard.
Uh-huh, yeah. So, what it's showing is it's starting off with just normal battery voltage. In this case, it was 12.8 volts, okay? And the drop you see is when they turned the key and started the engine. As the starter motor cranks, it takes power to crank the engine, right? That's why it dropped down to 10 volts. So the system only had 10 volts while the starter was in motion, right? And then once the car started, the alternator starts charging, you see the voltage come up to higher than it was to start with. Because the alternator is now charging the battery,
Oh,
okay? All right. That picture's probably in the book, isn't it?
It is.
500.
Yeah, okay,
I
okay.
saw it after.
Yeah, okay. Yeah, it's probably easier to see in front of me. All right, graphing multimeter, abbreviated GMM. It's a cross between a digital meter and a digital storage oscilloscope, or a DSO. Shows voltage levels at places on the screen or in a digital readout. Kind of looks like that. Again, a lot of the scan tools have that capability now, such as this graphing scan tool. Many scan tools are capable of displaying voltage levels captured on the screen through your diagnostic connector. This feature is helpful when changes in voltage are difficult to detect looking at numbers and are constantly changing. That is the purpose of the scope. All right. Again, as we go through these, if there's a test question on here that's going to be on the test, I'll tell you, okay? Highlight it, do something with it, so you make sure that's one of them that you know for sure. I see you brought us all lunch again, thanks. You're not sharing, is that what you're saying?
I'm doing a bike.
Good morning.
Morning, how are you? All right.
that number one?
I'm stuck between
It's four,
AC signal or pulse trains.
it's on 498.
Yeah, that's what I was looking at, it says pulse trains differ from AC signal in that they do not go below zero. I'm not sure if that's talking about the AC or the pulse train. And that they do not go under zero. I went back to AC and only thing that says anything about going under zero is in pulse trains where it says, DC voltage that varies up and down and does not go below zero. And that's talking about the DC voltage, but it says it does not.
You're overthinking.
Hey, that's your job.
Yeah.
I hear it.
It's nothing about overthinking, it's just that it
You are,
doesn't
though.
specifically say it.
It does, it says the DC voltage that turns on and off in a series of pulses is called a pulse train. Pulse trains differ from AC signal in that they do not go below zero.
Yeah, but is it saying the AC signal doesn't go below zero or the pulse
No,
train?
it literally says pulse trains differ
Yeah.
from AC signal
Yeah.
in that they do not, it literally says it. There's no
I know that's what it says, I'm reading exactly what you're reading.
So,
But I'm not understanding if they're saying the pulse train or the
Yes.
AC signal.
they're saying the pulse train, Rob. They really are.
We'll find out.
I know, I see your brain stuck.
Cause I wasn't here for this. I went down to grab my highlighter while you guys went over this.
No, so you're right on track. It's literally, that you really didn't miss anything.
If it's not pulse train,
It is pulse train.
if it's not, you're not sitting up here anymore.
You're really, you want the front row. I don't think you have that authority.
I'll lay down on these chairs. And pull a Forrest Gump.
Samples.
Over there playing with fire?
Mm-hmm.
You over there playing with fire?
Mm-hmm.
Is that a soldering iron?
Mm-hmm. Yep, it is.
Dude.
Shall we do it?
Mm-mm.
All right. Let's go.
Voltage signals, waveforms that do not go below zero are called pulse trains.
Are you sure?
I don't know.
All right, that's correct.
Okay.
Number 2, a throttle position sensor waveform is going to be observed. At what setting should the volts per division be set to see the entire waveform from 0 volts to 5 volts? A.
A?
I
B.
wasn't sure about that when I was looking on page.
Well, there's
46.
typically 10 divisions per, or 10 divisions horizontally on the scope, right? Or vertically, I mean, because you're going to look at voltage vertically, right? So it should be about 1 volt per division on that one.
Yeah, it says it on 497.
Yeah,
Oh,
okay.
497?
Yeah. Right under figure 43-3.
Now I see it.
Okay, 3.
What type of display low voltage without taking input? I think it's A.
Analog, yeah, okay.
I got C from
You did? Okay.
Is that right?
It's A on
No.
page 496.
Increasing the time-based setting reduces the number of samples per second. A for number 4. 5. You're up, Taryn.
Circles or cycles before seconds are expressed in hertz.
Yeah.
Are they?
Yeah.
Okay. Okay.
6.
A, number 5.
Yeah, 5 is A.
Yes, cycles per second is hertz. Which of these is measured as a percentage? Duty cycle is the correct answer. Put a note by number 7. Why?
On the tip.
Okay. You will see that one this afternoon.
Number 7 was A, you said, right?
Get it wrong, it's your own fault.
Number 7?
What is it? What's the answer to it?
A.
A, right?
Okay, all right.
A digital threshold, what the hell? A digital storage oscilloscope is set to begin displaying a waveform when a certain voltage is detected. The minimum voltage is called threshold.
Trigger
I couldn't
level.
find it.
Trigger level, yeah.
Yeah, I couldn't find it. I guess.
Minimum voltage is
Page
called the
500.
trigger level.
Yeah,
That's when it's
here.
gonna start
I couldn't
displaying a
find it.
waveform.
I think I'm just tripping today. I don't know.
You are tripping today.
Number 9, a typical DSO display screen is arranged in, I think it was on the first page, A, 8 times 10.
8 by 10 grid, yeah. All right. Anybody remember the lead, what they call that lead connector on that?
B and C.
The BNC, yeah, okay.
No,
All
that's a B,
right.
Yeah,
9J,
it's
yes, sir.
What was number 1 was C or
Which one?
number 1?
Post
Number
trains.
1,
Number 1 was B.
B. You got them all now?
So number 7 is the only one that's gonna be on the test.
So far?
Question. So these next 3 weeks, each chapter we're gonna do a test for that goes to our grade?
Yep.
Yep,
Gotcha.
yep, absolutely. Every time we do a paper test, it goes as part of your grade. Those are the ones that you need to do very well on. Especially if you're on the edge right at this point in the class. Okay, we did 1 and 2, right?
We did 2.
No, we didn't, okay, we did 1. That same one's gonna be on the test, right?
It's too deep.
Setting.
2 is D, yes. Yes. Time-based setting to 50 milliseconds per division will give you 500 milliseconds, if you have 10 divisions. Okay. Let me see, I believe this one might show up too. Okay, you don't have this in front of you, but this question is also going to show up on the test. I told you that when we saw it on the slide, remember? Difference between an LCD and a CRT.
They're
That
flipped.
is wrong.
They're both flipped. They're both wrong.
You got it backwards?
Yeah. Analog is CRT, and digital is LCD.
No. Digital scope can use CRT. So technician B.
Mm-hmm.
It says on the second one, a digital scope commonly uses liquid crystal display LCD, but a CRT may also be used on some digital scopes. So technician B only.
Okay, you got that?
Yeah.
It's V then, right?
Yes.
It's technician B, and it's going to be on the test. Whatever it takes for you to remember it, you better remember it.
Pulse trains, we did that one.
Okay,
Digital meter that can show.
this one is too.
Is that,
Is that on C?
We on 5.
yeah.
What's the answer, number 5?
DSO,
Mm-hmm.
digital meter, DMM, B.
GMM, graphing multimeter. See where it says a digital meter that can show waveforms? A graphing multimeter, GMM. Okay? That one is also going to be on the test. Cycles per second is expressed in,
Hertz.
okay.
The time base.
Increasing the time-based setting reduces the number of samples per second. This is your X and Y axis.
What number are you on, 8 or 9?
8. Voltage is
Or no, actually, this does not say X and Y, does it? Okay.
No, it just says
Yeah,
Technician B.
horizontal displays on the axis.
Technician B.
yeah, B.
Voltage is on the y-axis.
The horizontal, no, vertical.
yeah, time is horizontal,
Yeah.
not voltage. Voltage is vertical, okay? Easy to remember, V and V, right? Voltage is vertical,
Mhm.
okay? Time is horizontal, so it's just B, okay? We did this one. Duty cycles measured in percentage,
Trigger level.
and trigger level, we did that one, okay.
Book.
See what we got here. Okay. Anybody know how wire is measured? It's measured by gauge or square millimeters.
A wire?
The wire diameter,
Oh, the diameter. Okay.
okay? You've heard of different gauge wires, right?
No.
Let's see here. What are we gonna use? We'll use this, I guess. Let's say you have an 18 gauge wire and a 2 gauge wire. Which one's bigger?
8.
18.
No.
The two, because the lower the number, the bigger
Exactly.
the wider the
Don't
diameter.
mix it up. The smaller the number, the bigger the wire. A 0 gauge wire is huge, like a battery cable. An 18 gauge wire is like like this right here. Okay? Big difference, right? They're also measured in square millimeters because somebody decided we had to adopt the metric system years ago. A lot of times on a schematic, you'll see the wires shown in square millimeters as far as diameter goes. Okay, we're gonna go through that wire gauge system. There is obviously a chart for that in the book. We didn't do the quiz question in the book, did we? Okay. Was there any new ones? Anybody look at these?
I think number, I just did a quick scan, I think number
2 is a new question.
I think one is too.
1 is,
Is one?
number 4,
Okay, question 1. Tech A says analog scope can store waveforms for viewing later. No, it can't. B says trigger level has to be set. Does it?
what number?
Question 1, page 501. Everybody should be there.
Yeah, it must be set.
Okay, so it's technician B, right? What's the display called on an oscilloscope?
Division. Grid.
Maybe.
It's called a graticule, yeah. B. Okay, signal showing battery voltage displayed on a digital storage oscilloscope. This Tech A says the display shows one horizontal line above the 0 line. Tech B says the display shows a line sloping upward from 0 to battery voltage level.
Above the 0 line.
What's that?
A.
Somebody else will look that one up. I don't know the answer to that. 4 we did, 500 milliseconds, right?
Mm-hmm.
Raw position sensor waveform is being observed. At what setting should volts per division? We did that one, right? 1, okay. 6 is a new question, right? DC coupling. Tech A says that position allows DC, both AC and DC signals. Tech B says this setting allows just DC waveform to be displayed. On DC coupling, it's just A, I believe, so 6 should be A. 7 we did, 8 we did, 9 we did, and 10 we did. All right. Wiring and wire repair, we're actually going to do a little bit of wire repair later, okay? I brought in some tools to do wire repair. Solder, soldering iron, wire, connectors, wire tools, stuff like that. We can actually do some of that in the class, all right?
Okay.
So you can kind of get an idea of how to do a proper wire repair. Also brought in a test light. Everybody's seen test lights before?
Yeah.
Okay. This is your alligator clip, goes on your ground if you're checking for power, right? And this is your probe, poke whatever you want to look for power. Don't pierce a wire, okay? If you're looking for voltage in a wire, go to the connector, touch the metal part of it, okay? Okay, we'll do that later too. All right. Wiring wire gauge systems, purpose of ground wires, battery cables, jumper cables. Fuses, fusible links, circuit breakers, and positive temperature coefficient circuit protectors protect circuits and wiring. That's what a PTC is, okay? This steps for removing a terminal from a connector. Those would take special tools, so I'm not going to get too crazy with that because there's so many different ones out there. Performing the wire repair, which we will actually do, okay? Touch the electric conduit. Most automotive wire is made from what? Stranded copper with a plastic insulation, right?
Yep.
Okay. measured in two different ways, like we talked about already. It's either AWG, American wire gauge, size of the wire, or in square millimeters if it's a metric measurement. We've seen that already. Your best conducting metals down to the worst. That's your gauge chart. As you can see, a double zero is at the bottom. That's the biggest wire. 20 gauge is a very small wire. And whatever in between. There's your metric wire system. Metric compared to the American wire gauge size on the right. So for example, a 10 gauge wire would be 5 square millimeters.
Question.
Yep.
So on chart 44.4, it says that the recommended wire size increases as the length increases, right?
Yep.
So the longer the wire is, the greater the resistance.
Yep.
The larger the diameter, the lower the resistance.
So the longer distance a wire has to run, the bigger it has to be. Especially if it's going to carry a lot of.
In diameter? The bigger
Yes.
it has to be in diameter. So it basically, between the length and the diameter, it equals itself out?
I'm not sure what you mean by that.
Length and the diameter, so if you were to have a skinny wire, let's say it's like 20 feet, originally like 10 feet would probably be best. If you were to
Yeah,
have it
if you,
thicker in
if
diameter.
you, if you look at the chart, it tells you exactly what you want to know. 44-4, top right hand of 503. That's how, at the top it tells you how long the wire is going to be. On the column on the left tells you how many amps the wire can carry and what size it should be. So if the wire is going to carry 20 amps and it's going to be 25 feet long, it should be a 10 gauge wire.
Right, but my question is, does it mean that the resistance, does it even itself out? Does it equal out?
You mean if you use the chart?
No, because the longer wire, the greater the resistance.
Right.
The
So
larger
so the way you
diameter, the
compensate for
lower
that
the
is,
resistance.
the way you compensate for the higher resistance in the length of wire is by making a larger diameter. So yeah, to answer your question, yeah, it would equal out.
It equals out.
Yeah. So if you use the chart and you use the right size wire for the length it's going to be, you don't have to worry about the resistance decreasing as the wire gets longer, because you're increasing the diameter as it gets longer. Okay, so it compensates for the decrease in, or increase in resistance, okay? We talked about that yesterday. It says if a conductor length is doubled, the resistance is doubled. Conductor meaning a wire, okay? Difference between an AWG and a metric system is just the way the wires measure. Ground wires, extremely important on cars today. Cars have a lot of electronics on them. Ground wires are very important. All vehicles use ground wires between the engine and the body, between the body and the negative battery terminal. Skin effect, that is a term used to describe how high frequency AC electricity flows through a conductor. You will see braided ground straps on cars a lot. Don't ever remove one, okay? And if you have to service a car, put it back on, all right? You will run into all kinds of problems if you remove a ground wire, if you have one that's not tight, okay?
Can't you remove it with the battery though?
I'm sorry?
The thing on the engine, get the battery out, you can move the ground wire, right?
You
Battery's
take-
not active.
When you take an engine out, you mean?
Yeah.
Normally, if you're gonna work on anything on a car that involves electrical, obviously you remove the engine, you remove all of the electrical, starter, alternator, that kind of stuff, right? So first thing you do is disconnect the negative battery, right? First thing you do.
And then you can move the ground.
And then, I'm not sure what you mean.
I'm trying to say something. He had to, disconnect the negative to move the ground,
And move it.
or to take it off.
If you disconnect the negative battery cable, the whole electrical system's dead.
So then you can move the ground.
Yeah, you should remove the ground of the negative battery cable, not the positive. Okay, that way you can't short out on something, and also the negative is typically easier to remove. Sometimes positive battery cables have fuse panels attached to them and stuff like that. So negative battery cable is always the one you're gonna disconnect, okay? You may have to disconnect both of them depending on what you're doing, but for the most part, disconnecting the negative battery cable is all it takes. Okay, battery cable is the largest wire in the electrical system, usually around 4 gauge, sometimes 2, because they carry a lot of amperage, okay? They're designed to carry the heavy starter current. They're usually 4 gauge or larger. Okay. Get something to write with and open your ears. There's gonna be a question on the test. It says something about a 6-volt system requires what size wire? As opposed to a 12-volt system. Years ago, believe it or not, cars did not have 12-volt electrical systems. They had 6-volt. A long time ago. The 6-volt system requires a larger wire, okay? Not smaller. Okay? Everybody got that? Okay. Jumper cables. Everybody's familiar with jumper cables. If you ever buy jumper cables, don't buy the bargain brand. Don't buy the cheap ones. Don't buy the ones with really small cable. Chances are they're not going to start the car. Okay? Buy the good ones, the heavy gauge jumper cables. It seems like there's tons of cheap ones out there that just don't work very good. They just won't carry the current.
2 things. One, you said 6-volt system requires larger wire, right?
Yep.
Okay, and then 2, my mom has some jumper cables she got from Burlington.
Mm-hmm.
And she tried to use them on my brother's car because it was impounded. We went to go get it out for him, and the battery died. Melted.
Mm-hmm. That's exactly what's gonna happen.
I've never seen that before.
Don't buy cheap
Bruh, it
jumper
looked
cables.
like-
If you're gonna buy jumper cables, don't
Like, if
buy
you
the
were to
cheap
put,
ones.
like,
Make sure they're heavy cable.
like,
At least
taffy
2
on a
gauge.
stick and put a torch
Right?
to it, it just drips. It's weird.
Are you serious?
Yeah.
I've
It
never
won't-
seen that happen.
Yeah.
It's bad.
It won't carry the amperage. It will literally melt the wires.
How is it even legal for them to sell something like that?
They let them sell it. It's just profit. They don't usually test it like that.
Yeah, so just keep that in mind, okay? You're not doing yourself a favor buying your $10 jumper cables or whatever, okay? They're garbage. Fuses. Fuse is constructed of a fine tin conductor inside a glass, plastic, or ceramic housing. Everybody should be familiar with what a fuse looks like. Hopefully.
Yeah.
Okay? There's a ton of them in this electrical center here.
Don't the cars nowadays, have like 2 or 3 fuse boxes? I think we went over that in the previous chapter.
Yeah, yeah. Almost every car will have an underhood electrical center, okay? Got fuses, relays, all that kind of stuff under the hood. And then there's gonna be probably 1 inside the car, sometimes 2 inside the car, because they have so many electrical devices on them now. Okay, so yeah, it could have 2 or 3 fuse panels in it. But it's going to have 1 under the hood for sure. Okay? Fuse rating is normally about 20% higher than the normal current in the circuit. We talked about that yesterday for a minute. If a circuit is expected to carry 10 amps, you don't want to put a 10 amp fuse in it, right? Got to go at least 20% higher. Not going to hurt anything. Keeps the fuse from being on the verge of melting every time that circuit is active, okay? Color bladed fuses, also referred to as ATO, have been used since '77. There's obviously different sizes. You can see some of them in that fuse panel there. Mini fuses, maxi fuses, and the PFE Pacific Element fuse. Used to protect wire from a direct short to ground. Most fuses have test points on them. You can test them with a test light. We looked at this before, did we, or not?
Yeah.
If you look at these fuses here, they have two little test points on them. Okay, you just put the test light on one side, and the other side, you got power on both sides, the fuse is good. If it lights here and not here, the fuse is bad, okay?
Have you ever seen those fuses that when you plug them in, they light up, so when it pops, they turn off?
I have.
Do you recommend those?
I don't know that they're any good, but I've seen them, yeah.
Okay.
I don't honestly have enough experience with them to tell you if they're any good, but normally stuff like that is not the best quality. It's just a novelty kind of thing.
Gotcha.
Circuit breakers, what is a circuit breaker?
Isn't that where like all the
Cuts off power if something's going wrong along the way.
Mm-hmm. Yep. Basically, what happens is they're made of these bimetallic metals that deform when they're heated. So what it does, it opens the circuit. Sometimes when they cool off, they will automatically close the circuit again. Kind of works as a off switch. The positive temperature coefficient circuit protectors are solid state without moving parts. Fusible links, that's just a piece of wire that is designed to melt as a non-flammable insulation so it won't catch fire. I don't have a piece of fuse link here, but it looks just like a wire. Okay? Typically it's going to have like a tan colored insulation over it. If a fusible link burns, okay, it's just like blowing a fuse. You have to replace that piece of fuse link, okay? So you have to replace that wire, okay? Don't put a regular piece of wire in place of a fusible link, okay? Mega fuses, those are used in vehicles to protect high amperage circuits such as your starter. Sometimes you'll see fuses as big as 250 amps in cars. To check a fusible link, to see if it's good or bad, all you have to do is grab a hold of it and pull on it. If it breaks, it's bad. The wire melted inside. Okay, what's that?
Can you repeat that, please? I was reading.
Okay, to check a fusible link. If you have a fusible link on a car and you want to check it, just grab a hold of it and just pull on it. If the insulation stretches and it breaks, then it's bad. That means the wire melted inside. And sometimes you can't tell by looking at them. Okay, so just grab a hold of it and pull on it. If it feels good, it's good. If it breaks, it was melted. Right?
Question.
Yeah.
Off topic, but on topic. Mega fuses. It says one of them are HID headlights or 4 HID headlights. What do the HIDs stand for again? What does HID stand for?
High intensity discharge.
Okay.
And they have an igniter that gets the process started. They're elaborate headlights.
Gotcha.
Okay. Replacing a fuse link, make sure you use the right stuff is all they're getting at. Again, your fuse rating should be 20% higher than the current that it's trying to protect. This Underhood Electrical Center, we've seen those before. There's one on the table. Okay. I believe there's going to be a question on the test about, let's see. Okay. Fuses are color coded. This is the standard color and amperage of fuses. You can tell what the amperage of a fuse is by looking at what color it is. You don't even have to read what's stamped on it. Right? What color is a 10 amp fuse?
Red.
Okay. What color is a 30 amp fuse?
Green.
Okay. If you want to verify that, you can look at these. All of the red ones say 10, 30. Blue is what?
Blue is 15.
15? Okay. Yellow, 20. Okay. Test points, there is a large version of the fuse so you can see it better. There's your test points. We can do that as well. We go out, look at the car maybe later. All right, fuse readings, amperage rating and color. We already saw that. These are for the maxi fuses, mini fuses. All that is just the size of it, right? It's for space. Obviously, the big ones have to carry a lot more current, so sometimes the maxi fuses just have to be bigger just because of the current they have to carry. To test a fuse, we will do that, okay? Put the alligator clip on your test light to a ground and then just poke the test terminal. Electrical symbols. Circuit breaker. What they look like.
What was the second one, same thing?
Yeah, so what they do is in schematics, they have two different types of symbols. One's like a international one, and one's like a, just, I forget what they call it, but.
So that one, it looks like an upside down smiley face.
This one?
Another one. So
This one?
somebody, yeah.
Yeah. So, a fuse, we've seen before, a fuse is just gonna look like this,
Yeah.
right? Circuit breaker's gonna look like that, but
So that's the most common one where it says it above it?
I think this is gonna be the most common one, yeah,
Okay.
as far as what you're gonna see in the schematic.
Got you.
Normal current flow, these are those PTC fuses, those are circuit protectors, positive from the coefficient. I don't worry too much about those. Chrysler likes to use those, you've probably seen those under the hood of Chrysler vehicles, if you ever looked in their fuse panels under the hood. They like to use those. Okay. Example of fusible link wires. Probably won't see this very much. They don't really use too much fusible link wires anymore. They do have some older cars, but this is what it looks like. Comes off this power block here. Okay, these are the ones you would just pull on them to see if they stretch. If it stretches and breaks, it's obviously bad. Okay. Okay. This is one of those batteries that has a bunch of fuses connected to it at the positive cable. 300 amp fuse goes directly to the positive cable. That protects the whole system. How do fuses, PTC circuit breakers, fuse link protective circuits are designed to melt and open the circuit if too much current flows through the fuse. Okay. Everybody knows what a wire terminal is, right?
Yeah.
The terminal is actually what's attached to the end of the wire to make a connection. There's a whole bunch of terminals right here. Okay, you know what terminals look like, right? It's the end that goes on a wire that makes a connection, okay? We'll do some of those as well. Is there another piece of heat shrink tubing on there?
We probably could have asked him for one of these.
Oh, yeah, you needed one of those back in the day.
I still need one.
You still need one?
Yeah,
This one.
Really? I thought you fixed it.
I did, but it's not fixed. It's semi-fixed. I haven't been able to find the right diameter
This one looks like it
with
might
the
fit just
right,
thin.
the right diameter of either end. because
Okay,
the
well,
battery cable is
maybe we'll
big.
go fix that today.
Hopefully.
That'd be a good idea, huh?
Why not?
Extra credit.
Sure, why not?
Teamwork.
Yeah, I'm having trouble finding the right diameter for either end.
Okay.
So it's like I had to do something that.
When it gets over there to her,
Not like it.
she'll check.
I'm sure I won't.
Hold on to this one. 'Cause
'cause this one looks like it'll fit.
Does it?
Yeah. It's
What do
Is
you
just,
think?
it any big enough though? Is the diameter right on the end of the
Hers.
wire?
Yeah,
It's a
if
battery.
I
looks like
remember
a-
correctly.
That one looks a lot like spacier than the one that we use, cause remember, I tried to dig that out with a fucking
You
flathead.
know what I had to do?
Do these
I had
colors
to
matter?
take a,
What's
a,
that?
a
Colors?
flathead and.
The
and break
colors
it.
kind of
Really?
coincide with the size
Ah.
of them. So you know,
It
blue
works.
smaller, yellow's a little bigger, red's kind of smaller. So sometimes they're color coded like that, but we'll take that thing out there, so. Just wanted to see what wire terminals look like. We'll play with them later. You don't have to send them down the row, so. Here, we can just bring them up here when we do wire return stuff, so, okay? Okay. Term, connector. Connector is different than a terminal, right? What does a connector do? A connector puts two pieces of wire together, right? You're connecting them. Terminal is at the end of the wire. Okay, that's what you put on the end of a wire to hook it to something like she needs. Okay? Some take a special tool to crimp them. Those are just different types of connectors. Solder. Solder is what? It's what you use to make electrical connections. It's kind of like mini welding, right? And you can use stuff like this guy right here to do it.
Yeah, it's
Right?
used in plumbing a lot.
You got a
Mhm.
break, you got a break, look,
What's that?
you got a break.
Very
You're
clean.
just on the torch.
oh my god. He's trying to make a flamethrower.
That's one of those things you're not actually supposed to do.
I did that in, middle school with an X spray bottle on the locker room.
Yep, we used to do that, kill spiders and roaches.
No, I just did it to fuck with people. I got in trouble for taking a lighter to school. though.
Yeah, I mentioned you did.
Like RPC.
Okay, so tin alloy, used to make good electrical connections. We'll do some soldering later. Crimping tools, we have crimping tools on the bench. We'll do some of those as well. Crimp and seal connectors, we'll talk about those. Aluminum wire repair. Solder for automotive is rosin core. There may be something on the test about that. Make sure you don't mess that up.
What was that stuff?
Always use rosin core solder for electrical or electronic for soldering, okay? They do make what's called an acid core. That's more, maybe plumbing type of stuff or something like that, if you're gonna put a couple pipes together or something like that. Okay, rosin core is what you want, butane powder soldering iron we have here, wire tools we have here. We'll do a little bit of playing with those. Those are nice splices there. If you have a good solder connection, it should be shiny. The solder should be shiny once it melts into the wire of the connector, okay? Butane torch used for heat shrink. It'll apply heat. You can use it to apply heat. You gotta be careful on this because obviously if you get too close to it, you could mess up the wire. We're gonna do some wire repair, so. Everybody see these crimp and seal connectors, or have you not? These are ones where you can put the wire in each end, crimp it, and then you just heat this and it just melts around the wire and it's got like glue in it, and that way the wires won't pull apart. Makes a pretty nice connection. If a wire repair is to be done under the hood where it's exposed to the outside, it needs to be weatherproof, okay? Which means don't tape it. Tape doesn't work. Tape falls off. It doesn't form a good protective seal. Electrical conduit. The colors actually mean something. Everybody has seen yellow and blue probably, right? And orange. Orange is high voltage, right, on hybrid cars?
Yeah.
You've seen the orange conduit over the wires. Anything orange is high voltage, means it carries over 60 volts. If it's blue or yellow, 12 to 42. Black, and that's just the conduit that covers the wires. That's not really designed to.
Quick question.
Yeah,
On the, on the starter, right, the starter,
uh-huh,
there's a part on it, that little, I guess it's a screw or something, there's that part on it that if you touch it, you can get electrocuted, right? That's the starter I'm thinking about, right? Because it's,
Space.
it's, the way it's positioned, if you had to get to like, there's a part on the starter that if you touch it, you get electrocuted, right?
no.
That's not the
You can't get
starter.
electrocuted from a car unless it's a hybrid. If it's a normal car with a 12-volt system, no, there's not enough amperage or voltage in there to hurt you.
Sure.
Maybe it was a hybrid. No, I was thinking, because when you were talking about the color coding and the connections and
Uh-huh.
everything, at one of the shops, I was helping to do a repair, and the guy said, don't touch that, because if you touch it, you'll get electrocuted. And I was trying to remember if it was a hybrid or not, and I believe it was, because the alternator's over here, and the starter's here. And he said if you touch it, you'll get electrocuted, so be careful, don't touch that part. No?
Not if it's a normal car. If
Maybe it
it's
was
not
a
an EV or a hybrid, no.
Maybe it was a hybrid.
And if it was, it would be some sort of orange conduit over the wire indicating it's high voltage.
Right, and
Yeah.
there wasn't, that's why it popped into my head, because,
Maybe what he meant is if you touch it with something, it's gonna arc. It's gonna, like,
that's what it was,
Yeah.
that's what it was.
electrocution, no, can't happen.
Yeah,
The only thing that'll light you
screwdriver.
up on a car is the ignition system. Like if you happen to have your hand on a spark plug wire, if it has, a lot of cars are coil on plug now, so there's really no spark plug wire. But if you were to grab a hold of a spark plug wire, that's 40,000 volts, that's gonna hurt. It won't kill you, but it's gonna hurt.
Oh.
Hey,
Oh.
Tiffany, did you tell Ron what they got you doing at Toyota?
Oh, no, I texted him that day,
Oh.
Yeah, she's really good at testing batteries.
yeah, it's not funny.
Okay, all right. So I think I'll be testing batteries. Okay, well, you'll be really good at it.
Dude, they had me doing that all day Friday. Thursday, I was just like shadowing people.
All right. Can I get somebody to, one short?
Oh, I passed. I'm good.
Is it? Anybody got two of them? Why am I one short? Guess I'll have to go make another one real quick.
Here you go.
I'll
Copy
take
his.
Joe's.
Oh, no, I'll say you can copy his.
I'll just run a copy of this off. Okay.
We're gonna tell him he's not getting a test because he failed everything. He said you spent enough time in the bathroom, so he took your test now to read it. He looks like, wait, what? No, he's making a copy for Tiffany.
So, does anybody remember going over anything that talked about the size of the wire for speakers?
All right.
Not unless you go to page 503 for the metric wire gauge, or no, page 502, American wire gauge. 20 to 22 gauge radio speaker wires. I don't know if that's what they're looking for.
Oh. Huh. Thank you, Tiffany. Are there any on this test that'll be on the other test?
What's that?
Anything on this test that'll be on the other test?
Probably. But I'll let you know
Okay.
as we go through it.
All right.
I can get all 10.
I'm sorry?
I can get all 10 questions. I can have all 10 questions.
You don't have all 10?
He said, can you have all 10? Like, how do you all 10?
Should I do all 10 questions?
Oh, he wants to do
Oh,
it
you want
again
to
by
do all
himself.
10 questions?
Oh,
Absolutely you can. Surely you can. No problem.
It's number 2 silver.
yeah.
Are there any Puerto Rican stores, Puerto Rican shops, for good Papaleo?
For what?
Papaleo. Empanada.
Mexican.
I wouldn't say it's a Puerto Rican shop, but I know. Are you looking for like a deli type thing or like a restaurant?
And it doesn't, I just
Doesn't
want
matter.
Papaleo.
They got delis in Las Vegas.
All over Vegas. What do you mean?
Do they have any butchers
Like
here? I
deli,
tried to
deli,
Google
like-
a butcher and it just.
They have.
They have one, but it's not near you. Like,
Yeah.
far as fuck.
Is it really?
They have a seafood place, Seafood
Oh.
City.
It's like
I
on
don't
Rainbow and
Where can I get it?
on Blue
Find
Dino.
deli?
It's like over there.
So it's like where they cook like.
Oh, it's
like
just far.
lasagna,
It's far.
You can get like
Like an
mixed
hour
chips and
far?
everything.
Probably.
Yeah, they're all over shit.
They can make like a whole chopped cheese.
It's far.
And not like specifically chopped cheese. They make sandwiches and shit. Like, but some of them probably make what you ask them. I know there's one over on Craig and what's that street? You know where Craig Ranch Park is? The back exit that goes on to Craig. Right across the street over there by Las Papusas. There's a deli over there where they make all type of shit. It's like, I don't even know the fucking name of it. It should be right behind Farmer Boys.
When I Google things out here, it's weird how it comes up. It's like, doesn't give me a place, or if it gives me a place, it no longer exists.
Yep, that happens.
Oh,
Because a lot of shit is new out here, and they have the lot of where it's supposed to be, but it's not built yet. So they put it online first. You kind of remind me of something. When I used to work my old job as an independent contractor, we had to deliver a safe to a Dunkin' Donuts, and it gave us the address, but the address wouldn't show up on the map. It told us to cross streets because it wasn't open yet. We drove all the way there, ran around for like 10 minutes, tried to call the people, nobody picked up because it wasn't open. So we had to call the warehouse. They told us, oh, it's over here, it should be by McDonald's. And as soon as she said McDonald's, we're like, we just went to that fucking place the other day, doing the same thing. So we went over there, there was a Dunkin' Donuts right there. We didn't even notice it the first time we went.
damn.
But yeah, it won't pop up on the map, but it gives you the streets, and you just gotta go there to see if it's there or not. So regardless of where I'm going, unless I know it's been open, I call first. If they don't pick up, I'm not going.
You done with all 10 of them back there?
Yeah.
Okay. Let's see how you do on all 10 of them.
Alright,
And then on the second 10, we'll go through everybody, okay?
alright.
Okay.
Number one, high voltage.
Number 1 is high voltage, yes.
Number two, I put B.
It's A.
Yeah, 0 gauge would be like battery cable. Remember,
Okay.
smaller number, bigger the wire?
Mhm.
Speakers don't require big wire. So it'd be A, okay?
Alright.
Okay.
Number three, silver.
Silver, okay?
Number four, red.
Number 4 is red, yep.
Number five, A.
5 is A, yes, absolutely right.
And number six, I put A.
Okay, a whole bunch of A's, huh?
Yeah, seven, the primary A.
Most automotive circuits except for some ignition components use primary wire. Okay.
Number eight, I put B.
B, AC, yes.
And then number nine, shiny.
Solder should be shiny if it's properly applied.
And then 10 is B.
And then 6 is what?
What's six?
10.
10.
You
I'm
read
sorry?
6 volt, it's 10.
Oh, large, A.
Yeah. 6-volt systems require a larger wire. That's going to be on the.
What was my, I need them all again, cause I was like reading and, yeah, going over the pages and, yeah.
Yeah.
What was 9?
C.
What was 9? Shiny.
8?
8,
B.
B.
7,
Primary.
6,
A.
6A, 5A, 4A,
3A.
3A, 2A, 1 is D.
ooh, oh yay, yay.
Okay.
That's A, that's A.
This question is going to show up on the test as well.
Which one? 2?
Number 1.
Which of these wires is most likely used for a starter motor current
A.
circuits? A.
A. 0.
0 gauge, yes. High current, low numbers,
6-volt
like
systems
0.
require larger wires. than-
Larger wire for 6-volt system.
The type of solder that should be used for electrical work is rosin
Rosin.
core.
Rosin core, okay. 10 amp fuse is red.
Yep. Why is thick wire used for the battery starter circuit?
This question's gonna be on the test.
To carry high
Both.
amperage current.
Is it both of them?
Both, right?
A.
Well, a lot of people
Voltage and
get
amp
this
go together?
wrong
Voltage
because
pushes the
they
amp.
answer it C.
It's A.
It is not high voltage, it's high amperage. A only. Okay?
Didn't you say it doesn't have a P or?
I'm sorry, what?
That's only if you're not, that's only if it's on a meter, like you're scanning it.
I didn't hear your question.
No, like I said, amperes doesn't have a P, so.
It has a P, but only on the meter, it's the ammeter.
Oh,
He's thinking of ammeter.
yeah. Yeah, so if you're referring to the meter that measures it,
6 is
they,
A.
they just put another M here, they eliminate the P, yeah.
6 is A.
The higher the number, what?
Smaller the
The
wire.
smaller the wire
The
diameter.
smaller the wire. Okay, it's backwards from what you probably think. Big number, small wire.
7
Low
is D.
number, big wire. Number 7 is what?
D.
What causes a fuse to blow?
A decrease in circuit resistance and an increase in the current flow through the circuit.
Both?
What do you guys think? You like D?
Yeah.
Okay.
A 20 amp fuse, normally what color?
How are we supposed to
Yellow.
remember that?
Yellow?
Yellow.
I got it open right to
Yeah.
it.
20 amp fuse is yellow. Okay.
Thick wires have lower.
Yes, they do.
Metric wire size is measured in unit of cubic
Mm.
square
Square
millimeters.
millimeters.
I remember now.
Okay.
Metric wire.
All right.
Oh shit.
I guess it's break time, huh? Let's take a 10-15 minute break. We'll get back to the next chapter. We've got, what, 3 more? 5, 6, 7. We got 3 more to do.
We got it.